Hi guys, today we're talking about multicellular organization of organisms. So we've talked about cells and now we're going to see how they build and how organisms are actually made up of cells. So that all starts when cells come together and they form tissues. Tissues are groups of cells that work together to perform a specific function. Organs are when groups of tissues come together to accomplish a specific goal. They work together to form a specific function or a related function. Organ systems is when two or more organs work together to accomplish a goal in a coordinated way to carry out a similar function. And then when organ systems come together, they make an organism. Cell differentiation is the process by which unspecialized cells develop into their mature in form and function. And then stem cells is a cell that can divide for long periods of time while remaining undifferentiated with no specific job. Cells work together in order to carry out complex functions in multicellular life. And what happens is that the organization of the cells help organisms interact between different types of cells. So cell communication is important for organism function because they communicate and work together in groups that form increasingly large and more complex structures. We start here with our cell. Our cell forms tissues when you put a bunch of cells together. When you put tissues together, we get organs. When you get organs together, you get organ systems, and all together, we get our organism. So if you think of the common organ systems you guys already probably know, you think of muscular, immune, cardiac, digestive. Those are all systems of organs working together that communicate with one another to keep our bodies healthy. And that helps the organism maintain homeostasis. Homeostasis is a stable internal environment that organisms and cells want to remain in. And if you think of what happens when you get sick, so you get sick, you may get a fever, that's your immune system responding. That tells your nervous system to spike a fever to try to fight off what's inside the immune system. You may not feel hungry because your digestive system is giving all of its energy to the immune system to try to fight off whatever this is. You feel tired in the same way. So, those are all of our systems coming together that help us fight off something that may be making us very sick. Specialized cells perform specific functions. So, when you think of a specialized cell, you think a skin cell, a nerve cell, a muscle cell. But we also have unspecialized cells in our bodies as well. And that means that skin cells always divide to form new skin cells. It would be very concerning if your skin cells started making a liver. That's what cell differentiation is. It allows different cells to mature into a specific form and function to do a specific job. All cells have a complete set of DNA, but when the cell becomes differentiated, it only turns on the DNA that it needs to be that specific type of cell. Differentiation starts with stem cells. Stem cells are the first few cells that are developed and grown after fertilization happens. So, after the joining of an egg and a sperm, we get stem cells. Very quickly after, though, they become more specialized cells that can no longer make other types of cells. Stem cells have the ability to develop into any different type of cell. These are unique cells that can divide and renew themselves for long periods of time, remain undifferentiated in all forms, which means that the DNA, all of the DNA is turned off. They only have the control mechanism for division, and they can develop into a variety type of specialized cells. When a stem cell divides, it has the ability for two things to happen. It becomes two new stem cells, or it becomes a differentiated cell. There are multiple different levels of stem cells. And they're categorized by their ability and potential to develop into differentiated cells. The most undifferentiated is called a totipotent cell. This cell can grow into any other cell type. It's only the fertilized egg and the first few cells produced through the first few divisions of the embryo that are totipotent stem cells. This only lasts about 3 to 5, maybe even 8 days after fertilization. Then they move into pluripotent cells. These stem cells can grow into any cell type except for the totipotent stem cell. And then multipotent stem cells can grow into cells of closely related cell family. So once differentiated starts, they cannot divide backwards. They can only further differentiate themselves. So here you see like your fertilized egg. These cells can go into any cell type of any new organism. Embryonic stem cells can go into almost any type of cell except backwards. So we can never work to the left, we can only work to the right. And they can become any type of cell in the body. And then your multipotent are your adult stem cells, which are kept inside of your blood and inside of your bone marrow as an adult. Adult stem cells stay differentiated cells that are located amongst the specialized cell of many organs and tissues. The older you get, the less of these that you actually have. And they're found most abundantly in children and in the blood from the umbilical cord. Many parents are actually saving these stem cells from the umbilical cord for future use for just in case purposes. The last thing that you want as a parent is to find out that your child needs some type of organ and they can't find a donor. These stem cells can be broken off and grown into whatever differentiated cell that we need, whether that be growing an organ or just blood transfusions. The advantages to having those adult stem cells saved from birth or pulled out of an adult is that they are taken from the patient, grown in culture, and then put back into the patient. This lowers the risk of rejection from the immune system of the patient because it's their own cells, and it avoids a lot of the ethical issues that are surrounding the embryonic stem cells. Disadvantages is that the older you get, the fewer in number they actually are, and the harder that they become to isolate and grow. The older they are as well, they may contain more DNA abnormalities than the embryonic stem cell. Embryonic stem cells are those that come from donated embryos that are grown in clinic. There are a lot of ethical issues around embryonic stem cells, and a lot of people don't feel that we should be doing this. As someone who studied science for 6 years, I see the scientific side of it. As someone who wants to be a mom, I see the mother side of it as well. What happens is these are the result of in vitro fertilization, which is the fertilization of eggs outside of the woman's body. A lot of women are leaning on in vitro fertilization in order to get pregnant. So what happens is they would often use more than one egg to increase the risk of fusion of egg and sperm. But what happens with the rest of those? If all of the eggs and sperm are fertilized, what happens? There is the option that they could be donated for science, and that creates stem cells. They're taken from a cluster of undifferentiated cells that are about 3 to 5 days old and not yet, it's still forming an embryo, but it's not yet differentiated into the different types of the body. And this is where it poses a lot of questions. Is this right? Should we be taking away someone else's opportunity at having a baby? Should we be taking donations from sperm and egg donors to make embryonic stem cells for research? There's so many questions about this, and there's not really a right answer. They don't have any characteristics of any cell type. Remember, we're pulling totipotent stem cells, those that can become literally any other type of cell in the body. They have the ability to become one of over 200 types of human cells. But because they are not from the patient themselves, they do run the risk of those cells being rejected by the patient's immune system, or they can grow unchecked and form a tumor, which poses that question, is this truly ethical? Should we be doing this? However, current research has given us hope for treatment for patients with leukemia and lymphoma, creating lymph nodes for them in blood transfusions for those that have this blood cancer. And we're using these stem cells to test various different cancer treatments on. And it's offering hope for possible treatments. Potentially down the road, new drugs could be tested on a large number of these undifferentiated cells that have been turned cancerous to learn how a body could react to these cells.